हमारा जो चैप्टर है वो सेकंड चैप्टर चल रहा था, यहाँ पे फोर्स कंटिन्यू था। तो इसमें मैंने आपको बताया हुआ था कि न्यूटन ने 3 लॉज दिए थे। न्यूटन गेव 3 लॉज। न्यूटन गेव 3 लॉज फॉर द मोशन ऑफ एनी ऑब्जेक्ट। फर्स्ट लॉ इज नोन एज लॉ ऑफ इनर्शिया। लॉ ऑफ इनर्शिया and inertia is what? Inertia is what? Inertia is an oppose. Inertia is an oppose. Okay.
What's it?
Inertia. I'm talking about inertia. Inertia is an oppose. I've told you before in the previous class. Okay. Now we talk about the second law of Newton's law of motion. So the second law of Newton's law of motion is based on the conservation of, is based on the momentum, linear momentum. So do you know that what is linear momentum? Linear momentum is nothing but the product of mass and velocity. And linear momentum is denoted by capital P. Okay. So we can say that the external force applied on any object is directly proportional to the rate of change of linear momentum. Okay. So we can see that this is the second law of motion, Newton's second law of motion. Is it okay? So if we derive this formula, we can find F is equal to m into a, where m is the mass of any moving object and a is the acceleration of the object, and F is the force applied on the object, external force applied on the object. Okay, is it okay?
Yes, sir.
I've explained everything in the previous class. Okay, if you have any doubt in the previous lecture, so you may ask. Any doubt?
No, sir.
Okay, so now if we talk about the third law of motion, so third law, Newton's third law of motion is nothing but the action reaction. Okay, so every action has its equal and opposite reaction, and I have told you before another thing that action reaction pair doesn't act on the same object. Action reaction pair doesn't act on the same object. They act on the different objects. Okay, so consider that this is the ground surface and a block of mass small m is kept on the ground surface. Okay, so this block has some weight. This block has some weight. Everything that contains a mass has a weight also. So the weight of this object will be in the vertically downward direction. So that will be mg, and mg is balanced by another force that is acting on the block by the ground. So that is called normal force. That is called normal force. Normal force. That is called the normal force. Okay. Is it okay or not?
Yes, sir.
Okay. So the direction of normal force is what? Direction of normal force is what? Perpendicular to the contact surface. Okay. Perpendicular to the contact surface. Perpendicular to the contact surface. Okay. At the first, if you have to find the normal force, how many normal forces are acting on the object? So at the first, you may find the number of contact surfaces. If there are one contact, there is only one contact surface, so we can say that there is only one normal force. Okay. And normal forces always act perpendicular to the contact surface. So at the first, if you have to find the direction of normal force, so you have to find the contact surface first. Okay, you should have to find the contact surface. If we talk about this diagram, a block of mass small m is kept on the surface. So we are seeing in this diagram that this block is kept on the surface. So if we talk about the contact surface, so this is the contact surface. This is the contact surface. Can you see this?
Yes, sir.
Okay, so this is the contact surface. Are you getting me or not?
Yes, sir.
Okay, if you're getting me, it's very good. So if we have to find the direction of normal force, so the direction of normal force is perpendicular to the contact surface. Perpendicular to the contact surface. Is it okay? Is it
Yes,
okay?
sir.
Okay, very nice. So I'm erasing everything from this slide. Okay. Okay, I'll share the screenshot with you. No problem.
Okay, sir.
Okay, now we are going to discuss a very important topic, conservation of linear momentum. Conservation of linear momentum. Okay. So at the first, we should know what is the linear momentum. I have told you before in the previous class. Have you remember what is linear momentum?
So linear momentum.
Yeah. What is the definition of linear momentum?
Sir, I don't remember that.
It's not fair. You have to learn every concept properly. Okay. So linear momentum is nothing but the product of mass and velocity.
Mass.
P is equal to m into v.
Mm,
Okay.
yes.
So we have to discuss about the conservation of linear momentum, how linear momentum will be conserved. So as we know that by Newton's second law, F external is equal to delta P divided by delta T. And as we know that F external is what? Force applied on object, force applied on object. Okay. And if we talk about the what is delta P, so delta P is nothing but the change in momentum, change in linear momentum, change in linear momentum. Okay. And if we talk about what is delta T, so delta T is nothing but the change in time, simply change in time. Okay. Are you getting me or not?
Yes, sir.
Okay, very nice. This is nothing but the change in time. Okay. So consider that net external force on any object is zero. Net external force on any object is zero means what? The force applied on the object is zero. I mean to say that no force is acting on the particle or the system. Okay. So if no force is acting on the particle or system, so system means what? The combination of some particles. System means what? Combination of some particle. That this is an example of the system. Okay. The first block, there is a block of mass m1 is kept on the ground. Okay. And another block of mass m2 is kept on the mass m1 block. So this completely is known as the system. This completely known as the system because this system is made up of two block and ground. This system is made up of two block and ground. Are you getting me?
Yes, sir.
Okay, okay. Now if we talk about the net external force on any object, on a particle, on a system is zero. So if F external is zero, so by this equation, we can say that delta P divided by delta T, that must be equal to zero. And if delta P upon delta T is zero, so delta T will go in this direction or comes with zero, so it will become zero. So delta P will be equal to zero. And if delta P is equal to zero, so what is the meaning of delta P is equal to zero? That's mean the change in linear momentum is zero. Okay. Delta P is what? Delta P is nothing but the change in linear momentum. Delta P is nothing but the change in linear momentum. So we are seeing in this expression that delta P is equal to zero. So we can say that if delta P is equal to zero means what? Delta P equal to zero means what? The change in linear momentum is equal to zero. Are you getting me or not?
Yes.
So we can say that change in linear momentum, or we can call it only momentum. Okay. So momentum is zero. Change in linear momentum is zero. Okay. And now listen carefully. If if the change in anything is zero, so we can say that that thing is not changing. If change in linear momentum is zero, if change in linear momentum is zero, so we can say that momentum is not changing. Momentum will be conserved, will be constant. If momentum is not changing, So the change in linear momentum is what? That will be 0. Is it okay or not?
Yes, sir.
Do you need more explanation?
No, sir.
Okay. So delta P is equal to 0. So we can say that change in linear momentum is 0. So now P will be constant. P will be constant. Okay. P will be what? Constant. So we can say that linear momentum is conserved. Conserved means what? The thing that not changing. Conserve means what? Anything that is not changing, that is conserved. Or constant, we can call it constant. Is it okay? So we can say that
Yes.
the linear momentum is constant. But when is the linear momentum is constant? Only when the external force is applied on the object is 0. Okay. So look at here. Look at here. When F external equal to 0, P is constant. If F external is 0, so we can say that P is constant. Okay. So by according to the conservation law of conservation of momentum, we can say that when external force on any object, external force on any object is 0, its linear momentum will be constant. This point is clear to you or not? This point is clear or not?
Yes, sir.
What yes? Clear or not?
सर क्लियर हो गया.
Okay, very nice. Okay. So I think this point is clear to you. Okay, now
Yes.
let's take an example. Consider that this is a ground surface and two blocks are kept on this ground surface. Okay, one box is this and another box is this. Okay, and these are not only the boxes, these are moving boxes. The velocity of the this block is 5 meter per second in the rightward direction, and the velocity of this block is 10 meter per second in the rightward direction. Okay, so we can say that the velocities that is given, these are the initial velocities. These are the initial velocities. Consider that
Yes.
the mass of this block is m1 and the mass of this block is m2. Okay, the mass of this block is m1 and mass of this block is m2. So we can say that the initial velocity of mass m1 is 10 meter per second. So that will be u1 is equal to 10 meter per second. u1 will be equal to 10 meter per second. And one more thing, u2 is what? u2 is 5 meter per second. Is this okay?
Yes, sir. It's fine.
Okay, listen carefully. We have two blocks. Okay, we have two blocks of masses m1 and m2 respective. Okay, the velocity, the initial velocity of mass m1 is 10 meter per second and the initial velocity of mass m2 is 5 meter per second. Okay, okay, so this block is moving faster than this block. You can feel it, you can see in this diagram. The block of mass m1 is moving faster than the block of mass m2. So they will collide to each other. Okay, consider that there are two things. Okay, look at here, look at here. Palak, switch on your camera. Yeah, so look at here. Consider we have two objects. Object one is this and object two is this. Okay, so this object is moving faster than this object. Okay, so if this object is moving faster, this object is moving faster. Okay, so this will collide. with this object. This will collide with this object because this object is moving faster than this. Are you getting me? Okay. So when the two objects will collide to each other, their velocity will change. The velocity will change. Okay. Now, if we talk about this diagram, okay, let me draw.
Sir, just 1 minute.
Okay, okay. So I was saying that there is an object of mass m1 and another object of mass m2. M2 is slower down than m1. Okay, so they will collide because the mass of object of mass m1 is moving faster than mass m2. Okay, so they will collide to each other. Are you getting me?
Yes.
Okay, so after the collision, their velocity will change. After the collision, their velocity will change. This block is of mass m1 and this block is of mass m2. Now the velocity of this block becomes v1 and the velocity of this block become v2. Okay, so I am talking about this situation. If I am talking about this situation, so this is before collision. Before collision. Okay, and this situation is after collision. Okay, so by the conservation of linear momentum, we can say that the total linear momentum before collision is equal to the total linear momentum after collision. Okay, so क्या लिख सकता हूं मैं? Linear momentum before collision is equal to linear momentum after collision. Is it okay or not?
Yes, sir.
Okay, so if we talk about the linear momentum before collision, so before collision, the speed of ball one of block one is u1 and the speed of block 2 is u2. So the total linear momentum will be m1 u1 plus m2 u2. Momentum is what? The product of mass and velocity, nothing else. Okay, is equal to. Next, if we talk about the linear momentum after collision, so after collision, the speed of block 1 is v1 and the speed of block 2 is v2. So we can say that m1 v1 plus m2 v2. Is it clear or not?
Yes, sir.
So this is the formula for conservation of linear momentum. Okay. So now we can say that this chapter has been completed now. Okay. This chapter is completed.